Let's do a few more prime factorizations. So let's start with 34. And let's see what the prime factors of 34 are. So I'm going to start with 2, and 2 will go into 34 17 times. And now what will go into 17? Well, 17 is a prime number. The only thing that will go into it is 1 in itself, and then we're done. So the prime factorization of 34 is 2 and 17. And we can write that as a multiplication, right? 2 times 17, and that you can do the multiplication of all the prime numbers. Once you do the multiplication of all the prime numbers, you get back to the number itself again. All right, what about 36, which is only 2 more than 34? Let's see how it works. So we know 2 will go into it, and that leaves us with 18. 2 will go into 18, and that leaves us 9. And 2 won't go into 9, so I'm going to step up to the next prime number, which is 3. 3 will go into 9, and that will leave us 3. And what will go into 3? 3 will go into 3. So that's the prime number 3. So what do we have here? The prime factorization is we can take these two 2's and write the prime number raised to 2 because there's 2 of them. And then we're going to multiply that by these 3's. And we're going to do the same thing with the 3's. We're going to leave the 3 on the bottom and then raise it to 2 because there are 2 of them. So the prime factorization of 36 is 2 times 2 times 3 times 3. And if we multiply that out, 2 squared is 4 times 3 squared, which is 9, and that is 36. So we have all the factors of 36. Now, a couple of things when we're doing prime factorizations is that we want to write them in non-decreasing order. And so by starting with the smallest, you're going to get that. The smaller numbers always come first. But you put them in non-decreasing order, and when you do that, then you can compare. So we can see that 34 and 36 have at least one in common, right? They have 2 is a common factor, right? Now 36 has 2 of them, and 34 only has 1 of them, but they both have this common factor of 2. And so we can use this information to find out, well, what's the greatest common divisor, right? If we have everything lined up in the same way, we have all the prime numbers, then we can actually compare the prime numbers to find out this greatest common divisor and the least common multiple. Now I'm going to get rid of my calculations the way that I went about getting the prime factorization, which are really just my notes and my verification that I was there. And what we get is the prime factorization for 34 is 2 times 17, and the prime factorization for 36 is 2 squared times 3 squared. And these are both in non-decreasing order. And we can now compare them. Now notice that we can also in here put every single, to make these compare, we can say, notice that this one doesn't have any 3's. So we can add 3. Notice where we added. It's before the 17 because we want to keep that, maintain that non-decreasing. But how many 3's do we have? So this is actually really critical. We can't just put a 3 there. We have to say how many there are. And so there are no 0. Oops, that didn't work. And now I want to do a 3 there. There's 0, right? So there are 0 3's there. And when we do that, we haven't changed the value at all because any number raised to 0 is 1. So we still have, when we multiply these out, we still get 34. But now we can compare exactly how many 2's each have, how many 3's each have. And now down here, we're going to want to say how many 17's are down here, again, so we can compare them evenly. So now we do that, and how many 17's are there when we factor 36? We get 0 of them. So we list how many there are. So now we've just kind of filled in the gaps. Well, to find the greatest common divisor, and by the way, we often abbreviate it GCD, greatest common divisor. Now we compare the prime factorizations and we choose the least of each prime number. Okay, so for the 2, in 34 we have 1, in 36 we have 2, so we choose the least, which is 1, 2. And so that's what we use for the greatest common divisor. And then we go to the next one. In 3s we compare, and the one that is the smallest is 3 to the 0, right? And so that's the one that we include in our prime factorization, in our greatest common divisor. And then we look at 17, we've got 1 up here and 0 down here, so we use the smallest, which is the 0. So what do we end up with? 3 to the 0 is 1, 17 is 1, and so we end up with just 2. So the greatest common divisor is 2. And we could discover that with the prime factorization. We can also do the least common multiple in a very similar way, but the way that we're doing this now is we look at the largest, right? So let me get these all on the same page. And we can compare them again. And now we compare the prime factorization. So here we have 1, 2, and we have 2 2s. For the least common multiple, we actually use the largest one. So in this case, the largest one is 2 2s. So we're going to use that. And then we're going to multiply it. In the 3s, we do the largest one again, which is 2 3s. And then on the 17s, there's 1 17 is the largest, right? Because we have 1 and 0. So it's the largest, which is 17. So we use the largest, and this gives us the least common multiple. So we have 4 times 9 times 17. So let's go ahead and do that on a calculator. 4 times 9 times 17. I can make that small enough it fits in there. And we get 612. Notice that's not very small, right? 612 is the least common multiple of those two numbers. And we were able to figure that out by using the prime number factoring. Now, there's a relationship between the greatest common divisor and the least common multiple. And that is the least common multiple equals the greatest common divisor, it's the numbers themselves. So let's say that it's A times B, or A times B, the two numbers, divided by the greatest common divisor. So let's see if that works in this case. So we're saying that the least common multiple is 612 is equal to the two numbers, which is 34 times 36, divided by the greatest common divisor, which is 2. So again, let's get our calculator out to be able to do that. And we do 34 times 36 equals 1224. We divide that by the greatest common divisor, which is 2, and we end up with 612. So that's the relationship between the greatest common divisor and the least common multiple.